This is the Blockchain in Aviation Decoded webinar. And we're very excited to bring this information to you today. I hope that you'll find it very interesting. This webinar, let me just give you a quick format. We have a webinar that will run for approximately 45 minutes to an hour today. There'll be some presentation material that's given to you today, an opportunity to submit questions and answers. So feel free to submit questions, and we will answer the questions either during the webinar or at the end during the question and answer session. But let me go ahead and kick this off and say again, this is the Blockchain and Aviation Decoded webinar. And we have a couple of experts here today who are going to provide the core information. We have Michael Shea, who is the COO of eWINGZ, and he's on the left in the blue shirt with you today. And Michael comes to us with many years in aviation and degree in mechanical engineering, and his background brings to us a lot of interesting information in the technical area of blockchain. And then also we have the CEO of eWINGZ, who is Stefan Fossa, and Stefan comes to us as well. Yep, he's the one raising his hand in the black shirt. Thank you. And Stefan comes to us with a lot of good information in the industry and began the eWINGZ company. But they're going to be your panelists today, and they're going to be providing the core of the information. And as we get started here, Michael, I wanted to ask if you could scoot in a little bit into the screen. You're a little bit off the side of the screen. That would be great so that people can see a little bit better. Thank you very much. So gentlemen, I am going to, and actually now, Stefan, you're off the screen as well. You're going to have to go a little bit close. You guys are going to have to be nicer to each other. There you go. Thank you. All right. Very good. Wanted to make it a good experience for our people on the webinar. Thank you. All right. So gentlemen, I'm going to go ahead and turn the meeting over to you. Stefan and Michael, glad to have you with us today. Thank you.
Thank you, Mark, and thank you for this opportunity today to do this presentation to the aviation community and your network within the digital aircraft community. Little more on what Mark. Today we're going to go over within aviation first to bring an overview of some of the blockchain technologies and cover the information, give you information around blockchain and digital identity and elements within the aviation. First within the technology field or technology space. And we recognize that there are varying levels of knowledge. So we're trying to keep this at a level where in the conversations we've had with members of the industry, blockchain is, the word is known, what it means is highly variant. So for those of you who are attending the webinar today and are deep in the experience of knowledge of blockchain, we're dealing with the challenges you have already dealt with of a widely variant knowledge base of people attending. So we're trying to keep it, to give people a basic understanding of the blockchain and how it fits in aviation, and as well as provide good technical content around the relevance in the industry. So let me start and share the presentation, and we will get going. Okay, so as Mark announced, we're eWINGZ, a business located in Vienna, Austria, working in the aviation and blockchain, blockchain and aviation space. Our area of particular focus is in the maintenance, repair, and overhaul sector. But we will give you today a sort of go over what we're going to cover. What is blockchain and the concept of the commons. This is a key development within the technology space, and really is what blockchain enables within the information space or the internet or the web space. Next, we will cover digital identity. digital identity will be a key element of any solution, and we will cover that in depth, particularly in areas we believe that may not otherwise be getting some of the attention that it should be getting within certainly the typical conversations when you get into parts provenance. Finally, we will go into the maintenance, repair, and overhaul sector, which is our particular focus, and cover that and where we believe, cover what the eWINGZ offerings are, and how the previous 2 points build and enable the delivery of a strong MRO solution. So first is architecture. So this is going to be high level for, as I said earlier, for those that are familiar with the technology. We're all familiar with the centralized architecture. This is the internet of today. This is a centralized platform, portal, website where we go to and get some services, whether it's Amazon, whether it's Google, whether it's Facebook, whether it is some other centralized, like a Salesforce or other cloud-based solution. It may have multiple skins, it might be something as a service, but we are going to a centralized resource. We are all coming from our respective systems, PCs, and accessing it. The next move was really around decentralized, which is you start to fragment or break up the architecture, and you start to, actually similar is probably the hub and spoke system of air travel, certainly in the United States and some parts of, in Europe, where you have large centralized hubs that are feeding in and then moving from point to point. The new world within blockchain is what's called a distributed ledger. The distributed ledgers are the predominant architecture, though there are some other ones within the blockchain world. A distributed ledger is a peer-to-peer network, it's a sharing network. The key characteristics of distributed ledgers are either that they are a permissioned or a non-anonymous network, or a permissionless, which means the participants are anonymous / pseudonymous. It's a bit of a misnomer that you have anonymity in, actually not a bit, it is a misnomer. There is not anonymity on a blockchain short of Monero and Zcash, but otherwise blockchains are not anonymous. What the main difference between the two is the types of consensus algorithms, and it's how that information is validated on the blockchains in the distributed type ledgers. There are some other technologies that are will be lumped into when people just say blockchain, but they are not specifically distributed ledgers. Something like Holochain, which is a distributed hash table, or IOTA, which is another one that's got a fair amount of presence, which is what's called a tangle. It's a different, it's a acyclic graph. So it is a different technology, but it's doing a similar type of capability. When you talk or see within the blockchain world, there are really 3 predominant ledgers in the distributed ledger technology. For those who are in the know or who are more familiar, yes, there are actually hundreds of types of ledgers out there, or probably not hundreds. There's probably between 25 and 40 different types of ledgers, maybe a little bit more. But Bitcoin, Ethereum, and Hyperledger are the predominant ledger technologies. Bitcoin, and it's actually, interestingly, a little bit of a genealogy tree here as well. Bitcoin is the source. This is the famous white paper of Satoshi Nakamoto, published in 2009, describing this concept of a permissionless network where transactions and a crypto coin would allow the exchange of goods or exchange of value between two parties without a third party arbitrating in the middle. Bitcoin is it is a permissionless system. That means it's completely public ledger. Its consensus algorithm is what's called proof of work. There's an awful lot in the press and the media around the amount of power or energy that is used in the approving of the transaction block within the Bitcoin network. It is what it is. It's also how the value of the token or the coin is created. Bitcoin, all three of these ledgers are actually very vibrant communities, and there's an awful lot of work going on in all of them. The next one being Ethereum, which is, again, it takes its heritage from Bitcoin, but there is some significant departure. It still is, as well, right now, a proof of work platform. It is in the process of changing from a proof of work consensus algorithm to what's called a proof of stake, which then reduces the power requirement in the mining or the approval of the different block transactions in the blocks. The other most significant difference between Bitcoin and Ethereum is around what is you described or called as a smart contract. A smart contract is essentially a piece of functional code that is able to be written and stored on the Ethereum blockchain. That allows executable transactions to happen on the chain. Technically, from a purist standpoint, Bitcoin does have a capability of executing code. It is not really used. It's really not where Bitcoin has landed. The creation of Ethereum was able to leverage the baseline and expand upon it. The Hyperledger is a derivation of Ethereum. Hyperledger was originally created by IBM and was donated. The source code was given to the Linux Foundation, I think a couple of years ago in 2017. The main attraction of Hyperledger is it is typically a permissioned chain. Where this becomes attractive is in either closed ecosystems, where the value of a public permissionless chain really doesn't exist and there's not truly a good business value for keeping it there. Each of these chains has their strengths and their weaknesses. You will, depending on the individual you speak to, will hear either, you may hear the term maximalist, and a maximalist is someone who believes insert your favorite technology platform here is the only option and solution that is viable, good, or useful. I've got the experience, or maybe some of the benefits of having lived through those days with, way back with the Linux and Windows. I had my days of passion that way. Now I believe that all three of these technologies have appropriate places. And they're all, you really have to understand the business environment that you're trying to operate in to see which is the best one for the solution that you are creating or going to be using. So one of the big questions, and one of the things that you will always hear when you talk about blockchain, is storage. Oh, you'll hear, oh, we store this on the blockchain, or we store that on the blockchain. Oh, we're storing our part provenance, the the life cycle, the transactional, all this is being stored on the blockchain. This is really, it's incorrect. There is some information well, there's obviously information that is stored on the blockchain, but storing things on the chain directly is actually a very costly proposition. This chart here, this image here of what it costs to store a gigabyte of data, obviously varies depending on the date, specific date and time, as to what the value of an Ether or a Ether coin or a Bitcoin is worth. I don't remember right now which specific time and date or what date this graphic was created. The key is that the transactional size that you can actually store in the blockchain is in the order of 1 to 2K. So if you start breaking up a gigabyte of data and the number of transactions that actually turns into, that's where the cost comes from. So you really don't store the raw data on the blockchain. And so it's a misnomer or a misconception. If you were talking with people 18 months ago, everybody was talking very much storing on chain. Now everyone's realized, one, both from a cost and from a performance standpoint, storing on chain just doesn't make any sense. There's an awful lot of solutions now. Awful is probably a little bit incorrect. There's a good three to six different varieties of solutions that have been developed to deal with how to store data. Things like IPDB, things like IPFS. Those are mostly in the Ethereum world, and the Bitcoin world. Things like SideTree, things like Lightning, the Lightning Network. All of these are dealing around the storage and also the transactional cost issues that deal with, which would drive these $5 million and $23 million costs. So how does off-chain work? It's really, simplistically, not that different, simplistically or conceptually, from how a hard drive works. You have a fat table in a hard drive, which is essentially your index of where the data, the blocks of your storage are stored. If you've actually you've been around long enough to remember the drive optimization programs that used to exist, where they would reorder your drive so you would get those extra few milliseconds of access time improvement on your hard drive. I happen to have been around that long, so what you're doing essentially is creating a series of, when you write out the off-chain storage, is you're putting out a hash or an index into the blockchain. That's what's actually getting stored. It then refers to where the actual file or asset is stored, and it's used as a reference to deal with it. So you don't actually put the whole data. It's a little bit of a misnomer. It's not necessarily fragmented the same way or to the same degree as a fat table would be. But that's really the key part here, is that you're really only storing the hash on the blockchain. You're not actually putting all the data out there. So I mentioned earlier about, the start of the section was blockchain and the commons. What blockchain really brings is the ability to share information across organizations or across stakeholders and participants. It is really what would be termed in the past like a commons. It's creating a common resource or a common set of operating conditions, environments that mimic in many ways similar as the green, the commons deal from history and time, where people shared resources, whether it's a fishery, whether it's a field, whether it's trees or forests or finding truffles in the ground or whatever, where you have a limited resource and you're trying to then optimize how everybody gets to participate and gets part of it, and yet it's a competitive environment. This is what blockchain really is enabling. It's shifting the floor of what the capability needs to be within an organization and creating a common set of rules or executable code that everybody is using, which then brings trust within the ecosystem. There are multiple systems that are right now in production. Organizations like the Energy Web Foundation already have launched systems. Organizations like ISDA in the financial world, where again, they recognize the value of sharing capability is what is really driven or allows them to enable this. When we look at the aviation space, if anyone tells you, or you hear of any sales pitches or whatever, that someone with one chain is going to address the entire aviation space, I would encourage you to take that with a degree of skepticism. The space is just too big, too broad, too complex to say that every part of it is the same, that one chain will rule them all. It's not, I don't believe that's a viable configuration. Based on our understanding right now, we would break the aviation space into at least 5 areas: the maintenance, repair, and overhaul, passengers, cargo, airspace management, and airport management. These are all multi-hundred-billion-dollar segments or dimensions of the aviation sector. There is significant optimization and capability to be developed in each of these areas. And the business rules and business requirements are very, very different depending on which one you're talking about here. To say that one will do everything, quite frankly, I would regard as a little bit insulting, and it's simplifying with regards to any one of these segments relative to the others. The one thing that cuts across all 5 of these ecosystems is identity. Without identity in a digital form, it will be extremely difficult to realize the value. In our environment, which is, as you said earlier, is the MRO, identity is dealing with, we're dealing with all 3 dimensions of what is defined or as digital identity has been defined. Digital identity, the 3 dimensions are organizational identity, individual identity, and identity of things or parts. This image here just really sort of outlines the challenges within the MRO space. You have the National Aviation Authority that is issuing approvals for either license approvals to the technicians based on an application from the technician, approving training centers, and doing the licensing and approval of MROs. So you can see the interrelationships between these. To truly get the value and the learning or the productivity and performance improvements, this needs to be turned into a verifiable claim, verifiable credential with a digital identity. The technology exists, the technology is ready. The industry, that's what we're trying to accomplish with eWINGZ, is bringing the industry, bringing this technology to the industry. But the technician is only one part of the story. The part also has an identity. And as you're all very much aware, when it comes to dealing with the provenance and history of any maintenance operation. You have all of your airworthiness certifications. You have the ability to, the long-lived nature of the documentation in the aviation space, and the approval of whether or not a technician is licensed to work on a particular component or aircraft. All of these are things that need to be done. So this is really where we see as identity being an absolutely critical part in getting this right, which is where we've spent significant effort to make sure that the overall solution is successful. Just a little bit more on identity, and then I'll hand it off to Stefan. Like everything, it's the collection of data. So right now, and Stefan will go into more depth on the identity of the part, which we, within the eWINGZ solution, as a crypto tag with the UHF RFID tag. And you may have heard of other, had in other conversations about either, putting a lot of information into the tag, or how to continually add information to the tag over the life and history of the part. We believe fundamentally that's a flawed concept. That, again, the tag, the identity is a reference. You don't need to put all that information in the tag. The information actually needs to stay in the metadata service. And so that history of what happens to that part or component is added to the metadata service. So whether that is a part being added or removed from an aircraft, or a specific technician, or the MRO, or any of this stuff, it all starts to accumulate within the metadata service, not actually in the tag itself. This is a concept that's widely used in other industries. And I think it's something that actually is very helpful. It could be very helpful within the aviation space. I will now pass it on to Stefan. And Stefan?
Yeah, thanks, Michael. I'm a kind of Arnold Schwarzenegger, because coming from Neisling, Austria, and we're here right now streaming out from Vienna. And thanks, Mark, for giving us the opportunity, and also to the gentlemen watching our live stream right now. So we all know the issues in our industry, and especially in the MRO sector, and it looks like this. So I found this in the internet, and I found it very, very nice, because actually that was my experience in the last 30 years being an aircraft technician, engineer. Starting with cleaning an aircraft, then starting maintenance, being a normal technician, then going down the line in my experience in terms of leading teams, being a hangar queen more or less at the military for about 30 years. Then joined the civil side, and in 2009 I founded my own company for Camo Services, continuing airworthiness management organization, for those who are not familiar with that abbreviation. So too much paper, as we all know, creates a lack of transparency, and the lack of transparency, on the other hand, also creates lack of traceability. And that was our motivation and vision to found and start eWINGZ in 2017. After I don't know how many years, but I think I started in 2014 around, based on a friend. He told me, "Come on, let's put it on the blockchain," as Michael previously mentioned. And so I started digging into it, and eWINGZ came out of it at the end of the day in 2017. And we try to build here a secure platform where we allow data sharing based on standards who are existing and who need to be defined by the community, by the industry. So Michael talked about the identity, which is, we think, very, very important keystone. Most solutions out there, we miss them completely. And in order to make a network for the community, for the industry, you need to secure your endpoints. And what does it mean, endpoint? An endpoint means, for example, a node which a company is operating, is running. And therefore, you need to have, because we are moving, from a paradigm shift is happening currently, from a login password paradigm, you're moving towards a decentralized public key infrastructure, PKI infrastructure. And therefore, each time you generate a key there, you need to secure it on the endpoint by using secure elements. And you see this on the picture here, behind the thumb. This little element here holds the secure device on this board. So this is what we are building together with our partners, that we can secure and create trusted nodes so that everybody knows who operates the node. So just digging and tying towards Michael's explanation previously. So given the fact that we give parts a unique identifier using UHF RFID tags, you can link to those data or to those identifiers metadata. Metadata can be in form of a certificate. Metadata can be in form of measurements, what vendors need to do based on the agreements with the OEM. It can be anything what you think about. So it can be even be a cut drawing. So everything what relates towards the part, you can link to this identifier. So that means the identifier is enabling the so-called digital twin everybody's talking about, but in a very, very secure manner, because the technology we're using and offering to the industry is to have a secure identifier, and the identifier is part of the network, because we run some cryptography on the tag himself, which secures the identifier, giving him then thereafter in the network a secure identity reference. So how does this look like then? Just so the tier 2, 3, and 4 suppliers, they're producing their parts, which are needed then for tier 1s to assembly a unit. And as soon as they're building the parts, then they issue any document certificate. So that metadata set of such a certificate will then be hashed, and you see the little block up there, and will stored in the blockchain. And the metadata themselves, they will be stored in the metadata storage. And the metadata storage, you can run them on premise, you can run them within the cloud environment, shared with different companies participating in that metadata storage service. And as mentioned, they are interlinked, the data, the hash and the certificate themselves, they are interlinked. Because when you hand over the information towards the tier 1, and he is building, based on a bill of material, his parts, whatever the part may be, it could be an engine at the end of the day. So in receiving, when he receives the part in his logistics department, he scans with a UHF RFID tag the incoming of goods, and then he is doing his hashing function, and he's then cross-checking, is the hash I can calculate the same hash who is stored in the blockchain? So that's the basic idea behind what everybody anyway is doing. And in addition, because we use identity, we can then check is it coming from the right source as well? So there are ring signatures, who has heard about that, which will be used to do the verification of those verified claims previously mentioned by Mike. So what happens then thereafter in the value chain? The tier 1 supplier is building everything together, and then when he is ready with his testing and everything like that, so he links up additional information towards a unique identifier when he is issuing the first certificate of the part, which then goes out into his life cycle. And then it happens again. So it goes to the OEM, he's doing a certificate, installing it on the aircraft. Then maybe the MRO is also connected to the network. After a couple of years, the part needs to be removed. It goes into the supply chain, it will be repaired, it gets certified, and all this information is linked to the unique identifier. And yeah, that's more or less the way how you can enable the industry for track and trace capabilities using unique identifiers and secure part identifier based on UHF RFID tags. So the idea why we use UHF RFID tags is not really coming from us. The technology, the way how we're using, yeah, we co-invented it together with others. But the main idea is in the industry since 2007, and IATA has their own roadmap, and they put it really, really there to say it shall be used because it will enable the industry in all 3 segments of the value chain, from the vendor, from the OEM, and from the operator side and MRO side. Because of high data accuracy, what happens, because nobody needs to read and write data as a human, because you do this with UHF RFID tags and a combination of 2D data matrix, which is always on the tag himself. So let's see another form in terms of electronic records and how this can help all the stakeholders when talking about and using blockchain environment. On the top, you see the common stakeholders in our industry, lessor, operator, OEM, MRO, and National Aviation Authority. So imagine we have a new airplane and it's owned by a lessor, and he then issues a transmission declaration. We don't take the monetary part here, we just talk about maintenance records. And he then hands over more or less the OEM then hands over all the configuration management data he has generated during the building of the aircraft towards the operator. And with that data, and we together with the community, it needs to be standardized how we put that in. There are standards out there, and it needs to be defined during the time when building things. Is that enough? What's the standard? Does it need more adjustment, etc.? But anyway, the operator can do a digital application towards the National Aviation Authority in future. And then the MRO is also involved. And the National Aviation Authority sees then all the standardized data and capabilities of the aircraft based on the configuration management handed over to the operator. So, and involving then the MRO in that digital process, where, you know, just some key points in terms of registration mark application, Mode S code application, and EAT code. When all the tick boxes are ticked, what you need to do when you register the airplane, then the authority can also use a tagging mechanism, reflecting and linking the certificates we normally issue still in paper and down the road in the life cycle of an airplane that sometimes can create problems when you operate the airline because you're waiting for the certificate. You need to have it on board. So that can then be eliminated because it's in the digital environment and it's just interlinked towards a secure identifier which is sticked into the aircraft. When doing maintenance events, so the operator is putting his work package together and is handing it over to the MRO. And currently that works with emails. Some use EDI, but most of the parties I'm working with, might it be in the airline industry, business aviation world, they're doing this via emails. And that creates, forgive me my wording, a ton of mess. Especially, during the process, people are currently, involved in a lot of paper generation, and data sharing is time-consuming for both sides, especially for the MRO, because somebody, the lead technician or the planning department from the MRO, they have a heavy workload in terms of getting the information from their team, putting a status update at the end of the day together, and then handing it over to the operator, and vice versa. So all their proof of flow within that is really a nightmare. But what's very important is you can then interlink this information exchange, especially when you talk about standardized tasks. When using S1000T standards, for example, then you can link standardized tasks and put it in a distributed database, and then access the data from there. And each time a revision is coming towards those maintenance manuals, the new revision is getting also hashed. So you can cross-check again here that people have always the latest and greatest maintenance manuals in their hands. So there are solutions out there. It just needs to be put in place and use the technology in a new way. And there are good companies out there already using, having already good solutions out there. Needs a little tweak to make it blockchain ready, but that is not really the deep problem what we will encounter when building it. I think that's a very easy task at the end. So each time then when you release an aircraft or when you replace a part, you always need to timestamp the information for the project, and this happens normally when pilots are flying from A to B and using their electronic flight bags and updating the system. So you get them the data automatically into the system, the utilization data related towards the aircraft. And so you can then connect the timestamps received from the EFBs with the utilization of the aircraft. So you collect everything what's needed for keeping the airworthiness requirements on an airplane, just integrate it in the back end. And then, all the ERP systems out there, AMOS, tracks, whatever, they can connect to those data and reuse them and rewrite and add to their system based on standards, using them blockchain way we try to build together with you. So that was more or less my part of the presentation. So Mike will do a little recap and we'll wrap it up.
So just to go back over everything, we talked about today, the objective today was to cover these three areas. First, to give you an introduction to what blockchain is and the concept of a commons or open commons. The idea that really what blockchain is bringing to the table, where in the 90s and the early 2000s, the world of open source sort of came on the onto the field. Many people looked at it and said, how does this make any sense? Giving software away for free doesn't make any sense. I think we now know that actually it's an extremely powerful mechanism that enables innovation in a manner that any one individual organization can't do. Blockchain is of a similar nature. It's shifting the bar from the open source to an open commons, to allowing organizations to share what needs to be shared in order to meet efficiencies. Particularly in the aviation space, it's a highly regulated industry. There's a lot of things that everybody is doing. They're doing because it's required by law to do, not that it's a differentiator of your operations. Digital identity is a key component. Being able to securely identify and verify both organizations, people, and parts across the whole sector is ultimately going to be critical for the success. And finally, in the MRO, Stefan laid out where we see just a part of where we see huge value in the elimination of paper and the efficiencies that can be gained within the operations. So, sort of to wrap it up, some final thoughts. Why bother, right? Why should anybody actually care? Well, there's a whole lot of reasons. One is that margins are usually pretty tight in this industry. So increasing productivity, like many industry sectors, there's a demographic time bomb waiting to go off within this sector as well. Technicians, the number of new young people entering the technician job or technician role is not what it was 25 years ago. There's also not the same number of 25-year-olds today as there was 25 years ago. So the industry has to look at ways to making those technicians that are there be far more productive. Spending 25 or 30% of their day dealing with paperwork, whether it is stamping paperwork, reviewing paperwork, scanning paperwork, rekeying data off of paperwork, is not good business sense. Getting the paper back to actual data, it addresses a lot of the data issues when you start scanning things or manually rekeying data from a piece of paper into a system. These are huge data quality issues regardless of industry. This is not unique to the aviation sector. It's a big issue when you start having to retranslate data. Once you get the data and once you get the clean data, this opens up an enormous number of opportunities around process automation, around bringing in machine learning, bringing in artificial intelligence, making this data available. Right now, where release of service documentation is being rescanned and put into systems, either as PDF documents or TIFF images of documents, or maybe they're actually doing some OCR recognition off of the document. But that's from our conversations, the small minority of the businesses. So these are all things that start to become unlocked. Is there a work to be done? Yes, there is. But I believe we believe that there's strong business value here in order to pursue this further. So we'd like to thank you for your time. And Mark, I don't know, are there any questions that have come in that we should to be addressed?
Yeah, there actually are. Can you hear me okay right now?
Yep.
Okay, great. So we had one comment, and we've had quite a good participation here on the webinar today, so that's really great. And then we have some other questions that are coming in too. Let me start out with this. One of the participants said that training and qualification seems to be an opportunity for the use of this technology. Can you comment on that?
Yeah, I mean, use the technology, particularly in the areas of in a digital credential for training and qualification, is absolutely an area of the technology. It starts to create, this becomes a key part in that you have a digitally signed or credential that allows then the technician, instead of having to put a wet ink signature on a document, may use some sort of an NFC card or something of that nature, some way that they're using a digital fingerprint or a digital authentication of the paperwork, but which then ties back to make sure that based on the job card, that this technician then actually has the digital credential that says they're actually allowed to do the work and approve it. So it is absolutely a key part.
Yes, in combination then with the approval from the company that they say, okay, you can sign for us, and that then you can therefore we use the verifiable claiming technology in terms of that you can then reprove when you scan, let's say, a tag, then the system will check in the background automatically, okay, the organization was approved at the time when the certificate was issued, that they are allowed to whatever they do on the part, produce it, maintain it, whatever. And then it will tag the checkbox as well in terms of, okay, the person who signed it off was also approved by the company to do so. And this you cannot do with paper.
Yeah, that's really interesting. I think a lot of people think of the application of parts and signing of parts and records, but I'm not certain that people have thought through all the different possibilities like training and qualifications. So that's really an interesting insight into the situation. Hey, let me move on to the next question. I'm going to have to kind of summarize this, but there's one comment here that says that there's a few small airlines that are operating within some specific regions, and they're wondering how a platform like this can be used to seamlessly connect these airlines, in perspective of combining journeys or interline, connections through a platform. Is there some way that you would look at using blockchain for the application of that to networks and to commercial? What are your thoughts on that?
There are, sorry. Actually, there was an event last week or 2 weeks ago?
2 weeks ago.
2 weeks ago in UK, held by the Digital Catapult. And we have been invited there to participate and to share our ideas. So there have been workshops made. And yes, there are opportunities in terms of, especially to share information. And then on the other hand, the industry is already working on that. CET, for example, is doing a flight chain sandbox. So there are a couple of people out there, or we are working together with the SAE standard body in terms of talking about what does the standard body need in order to start standardization. So things like that are already happening at the end of the day in the background. So people are meeting, people are talking, people are sharing ideas, concepts, putting stuff out there. POCs are getting built, internally. What we do with that POC, what we mentioned right now on the screen, is actually a working group with a diverse set of industry members starting a bigger POC. So everybody who wants to join, just reach out to us via office@eWINGZ.aero. Then if you want to dig deeper with that, and join the proof of concept working group on 30th of August 2019 in Vienna, Austria.
Any other questions, or Mark?
Yes.
Yeah, so there was one follow-on question to that, and guys, you're the experts, and so I'm going to throw this out there because I don't know that I completely understand this. Is that this follow-on question was, hey, we'd like to have more of a decentralized kind of an environment where it isn't controlled by a particular organization, and these airlines might be interested in selling their services or managing their customers from this kind of an environment. Now, help me understand, how does that question apply to the use of blockchain?
Well, okay, so that is very relevant. I mean, so this is where blockchain, this is the idea of a commons. So if you're selling selling data, selling information, one of the challenges, and I'll focus more specifically here on the MRO, but I think the listeners, the participants here will be able to extend this to the other ecosystems that we talked about. If you look at just the maintenance, repair and overhaul sector, there are approximately 7 stakeholder roles of people who actually care about the data that the maintenance data, whether it's the lessor, whether it's the operator, whether it's the manufacturer, whether it's a regulator, the different tiers of manufacturers, all of the MRO, all of these people, all these organizations care. The challenge right now is it's all in paper, right? So if some maintenance is done, it's paper, then it has to go back to the operator. The operator has to either store the paper or scan it somehow. And if the aircraft goes off end of lease, it has to go back to the lessor, and so there's all this cost that's dealt there. The whole point of the blockchain is making this data available where the data doesn't actually start to move around, you move around the access to the data. Through cryptography, through multi-signature pieces of code dealing with this is really what blockchain brings to the table. This is really the novel piece of blockchain. It's making it available. It's creating this concept of a digital commons where you can share information across members that are interested or have a vested interest in the data.
Yeah. So and just to add on to Michael's, so we gave him a working title, or actually you gave it to it. So we call it also railway, because we put the data on a railway, so to exchange. So we don't use the terminology blockchain or distributed ledger. Internally, we use a railway, because there are other technologies used in terms of to make it happen as well. So blockchain, one key element, enabling, it is very powerful. That's the key message. You can do tons of things with it. So, but the key message is it's access management at the end of the day of data.
Okay, let me throw out one more question as we're approaching probably nearing the end of our time. We have a question here, which is really, how does someone work toward determining the value of the implementation of blockchain? What sort of factors could somebody look at in order to be able to assist in justifying the usage of blockchain technology?
I think one is you want to identify what is a specific sector that or what the specific segment of the business that you're addressing. It's not a one size fits all. Okay. I think you need to look at what that segment is actually specifically addressing, and you're looking at where your costs are, where do you see that the cost of operation, where you're going to either see a reduction in increase in productivity, either by moving into a digital process, and it's measuring things like data quality, like where you're having the manual re-entry of data. It's amount of time that's taken in those areas. They're not necessarily very sexy things, but this is where a huge amount of cost gets added in, and errors. Anywhere where there's manual interaction, there's a higher instance of errors. So I think that those are some of them, sort of quickly, without knowing very specifically what sector or segment that they're referring to. I think that's where I would start to look at.
Okay.
And ultimately it is a business case, right? This is not, it's cool technology, it's some neat stuff. There's also there's been an awful lot of stuff that people have thrown out over the last 18 months, which really don't have a business case. Blockchain makes sense when you have multiple stakeholder roles or multiple parties needing to share information, right? Or share process. If it's within one organization, a blockchain probably makes no sense. But if you are dealing where you need to share information easily across multiple parties, that's where it starts to make a lot of sense.
Okay. I have another question that's come in. Okay, so this has to do with how to enter part data, onto the blockchain. So the question is do you have thoughts on mechanisms and technologies to enter part data onto the blockchain for current tier 1 OEM and MRO processes, something that might be integrated with current MRPs or ERP technologies? So, what are your thoughts on actually getting part data, into existing systems? What mechanisms or technologies can be used in order to get data into existing systems?
So I think it's not Do you need to get the data out of the existing systems? That's more or less the question. Because the blockchain will not create any data, so it will store data, basically, and reduce it just to the hash. So there's of course more what it stores, but we reduce it just to the hash where we are interested in. And to start the digital twin, you need to have whatever PLM systems the manufacturers, tier 1, tier 2, tier 4 suppliers have. Some of the tier 3, tier 4 even don't have that. So most likely they may be connected to a tier 2, tier 1, where they then, print certificates for the part they're producing based on the agreements they do have with their tier 1 or tier 2 supplier. So it's a connected ecosystem afterwards, more or less. And the tier 1 or tier 2, who does the part design, actually, he is responsible then for putting the data into so already the other company connected puts data based on the requirements what those two companies have together into the chain.
So just to add a little, and I'll add it more from a pure block and tackling versus specifically, what Stefan just said from an industry knowledge and experience. One of the things that we are looking at is that every business has a different ERP system. SAP obviously is a large one, Oracle, there's a whole series of different technologies. What we're proposing is really in building part of the railway, which Stefan has talked about or mentioned, is that ecosystem that enables the movement of data, but then the building of connectors to connect into the different ERP systems. We're not proposing changing ERP systems. That would be suicidal. If that question, if that's where they were going, part of what part of what eWINGZ is in building these connectors to allow the different systems to easily access the data and bring that into the different ERP, whether it's moving data from the ERP into the railway or back the other way. That's what we're
Michael, or Stefan, and Michael, I think that was really the essence of the question. So it was really, how do I get my data onto the blockchain? And so what you're saying is that as a company, you're positioned to strategize with people and say, look, here's your IT portfolio, and these are the type of things that should be integrated with blockchain, and this is the mechanisms, like technologies that you would use to do that. And so you're really saying that you're positioned to have that thought leadership with people on how to connect those ecosystems, to your railway that you've talked about.
Yeah. Oh, yes, that's correct.
Yeah. Okay. Well, very good. So it looks like we've kind of come up on our time here of what we had committed to as far as this webinar is concerned. And if people have additional questions or want to follow up, what's the best way to reach out to you?
I'd say the best way is to reach us is at the email that's listed shown on the screen right now, office@eWINGZ.aero. And that's eWINGZ with a Z, like Boys in the Hood. Sorry, that was a bad joke. Anyways, that's the best way. We would love to speak with you further, whether it's to go further into your specific environment or to explain things further that you may have talked about today. If you're interested in the POC workshop, please drop us a note as well. We would love to have you.
Now, tell us one more time quickly, what is the purpose of that POC workshop and who's designed for that to participate in that?
So the POC is designed for a diverse community membership. So let's say distributors, parts producers, OEMs, and airlines. So that these are the participants.
Okay, and so if they would like to participate in that, they can reach out to you on that same email address, office@eWINGZ.aero?
That's correct, yep.
Okay, very good. All right, okay, well listen, I wanted to say that I appreciate you guys having this this webinar today and on blockchain and aviation, because it's a subject which has been a little bit confusing to people. It's fairly new, and when there's new technologies, it's interesting, but it isn't always easy to understand how it can be applied, in the industry. And so here at Digital Aircraft, one of the purposes that we have is to be able to connect people, companies like yourself, with people in the community and help us to create digital transformation faster and to be able to help people to connect with technology that's out there. And so any of you out there that would like to get in touch with eWINGZ, please reach out to them on office@eWINGZ.aero. And if you would like to be part of a webinar like this again in the future, please reach out to me on LinkedIn or at our website as well, and at DigitalAircraft.org. And we would be happy to work with you and or your company to do a similar kind of an educational series. Our goal is to be able to promote digital transformation in the aviation industry. And this is exactly the kind of thing that we want to do, is connect companies with people to be able to do that. So gentlemen, I want to thank you so much for this great information today. And I know your company is going to do fantastic. You got a great concept and you have some good foundation. And thank you very much.
Thank you, Mark.
Thank you, Mark.
All right,
Thanks.
Bye now.
Take care, everybody.
Thanks.